Hey everyone, in this video I'm going to show you how to solve ALEKS' problem called identifying the components of wax esters. There are two different versions of this problem and I'm going to walk you through solutions for both of them in this video. This first version, ALEKS is asking us to draw the skeletal structure or line structure of a wax. It could be formed from a particular fatty acid and a particular alcohol. And as a reminder, this is how alcohols and fatty acids come together to make a wax. So in order to solve this problem, I think we should start by drawing out the structure of the alcohol and drawing out the structure of the fatty acid so that we can put them together to make the wax. Now, starting with the alcohol, I can see from this formula that this is a 7-carbon alcohol. I have 1 carbon plus 6 carbons. I'm going to sketch that in line notation: 1, 2, 3, 4, 5, 6, 7, and don't forget the OH. Double check and make sure that you have all 7 of those carbons. Next, I am going to draw the structure of the fatty acid. Now, ALEKS is giving us the fatty acids by name. You probably don't have the fatty acids memorized by name. So what I want you to do is go to ALEKS' data table, which is, you can access that by clicking on this bar graph icon over here on the right. That's going to give you the option to open up ALEKS' table of fatty acids. And that's what I have showing over here on the right. Now, I definitely encourage you to always go to ALEKS' data tables for problems like this. The internet is full of all kinds of incorrect information. So going straight to the source is going to help you get this problem right on the first try. We are being asked to draw the wax that is formed from myristic acid, and that is the structure of myristic acid. That is a 14-carbon carboxylic acid or fatty acid. You can just count those carbons real quick: 2, 4, 6, 8, 10, 12, 14. So I am going to sketch that, just copy that structure: 2, 4, 6, 8, 10, 12, 14. Okay, so the formula for combining an alcohol and a fatty acid to make a wax, you can see that when this reaction happens, the alcohol and the fatty acid are both losing some atoms. The alcohol specifically is losing its entire OH group. Like, that just goes away entirely. You can see we're just keeping the R from the alcohol. And then for the fatty acid, we're losing that hydrogen. This reaction just produces a water molecule from those two parts that get lost. And so what I want to do with my drawing down here, I want to remove that OH. And I also want to remove that hydrogen. And then I just want to slide these two pieces together. I'm going to get rid of my plus sign. Slide these two pieces together. And that is the structure of the ester. Now, it is pretty easy to lose carbon atoms when you do this, when you draw this out. So the last thing that I would recommend is that you double check and count to make sure all of your carbon atoms are present. We had 7 total carbon atoms in the alcohol, and we had 14 carbon atoms in the myristic acid. So we should have 21 total carbon atoms in our wax. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And just as a word of advice, if you are losing a carbon atom, most likely it's going to be that carbon atom right there. That's the one that people tend to lose. All right, so moving on to the second version of the problem. This one is just basically the same problem in reverse. It's going to give us the structure of a wax, and it's asking us to identify the structure of the alcohol and the fatty acid that were used to generate that wax. There's a little bit of a story here that varies from one problem to the next, but it doesn't matter. You don't have to pay attention to that. So this problem, like I said, we're just working in reverse. We're starting with the wax and we're working our way backwards to the alcohol. So focusing on this, what we want to do is identify which portion of this molecule came from the alcohol and which portion came from the fatty acid. I think it's easiest to start with the 2 oxygens and the carbon in the molecule. That's kind of like a good benchmark for a starting spot. So that right there. What I recommend you do is start with the first oxygen, by that being the oxygen that's kind of in the middle of the carbon chain, and then work your way to the second oxygen, and then just keep on going down the chain, and that portion of the molecule is your fatty acid. Now, it is really important, it's essential that you get this correct, meaning that you go in the correct direction to identify your fatty acid. If you go in the wrong direction. So if you go this way with it and you say, oh, that's my fatty acid, you're gonna get the problem wrong. So again, start with the oxygen that's in the middle of the chain and work to the second oxygen and then work your way down the chain. That's your fatty acid. And the other portion of the molecule is your alcohol. So let's see, I'll highlight that in a different color. And ALEKS wants us, for the alcohol, ALEKS wants us to write its chemical formula. So this is gonna be CH3, and then we have 1, 2, 3, 4, 5, 6, 7 CH2s. And then don't forget that at the end of this alcohol, at the end of those carbons, we have this OH group that gets removed when the wax is formed. So we have to add that OH group back to the structure or to the formula of the alcohol. So there's our alcohol. The other component, which is the fatty acid, we have to identify that by common name, which is the names that are being used in ALEKS's data table. What we're going to do is find this fatty acid based on its structure. I can see that this fatty acid is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons, all single bonds. So I'm just looking through this data table to find the fatty acid that is 12 carbons, all single bonds, and I believe that it is lauric acid, 2, 4, 6, 8, 10, 12. And so we're just going to write that, copy that, spelling counts. And also you do need to add the word acid at the end, even though that is not present in the name in ALEKS's data table. It does need to be included in the name for this problem in order to get it correct. Good luck. Let me know in the comment section if you have any questions.